Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by SatSearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello and welcome to the episode. I'm joined today by Zdravko Dimitrov, CEO of Sfera Technologies. Sfera is a Bulgarian new space company that develops technologies to integrate satellite data systems. Today, we're going to talk a little bit about innovation in the use of blockchain technologies for satellite ground station services and related systems. So, Zdravko, thank you very much for being here with us today.
It's good to be here. Thank you.
Right, fantastic. So, let's get into this topic. I mean, blockchain technology grabs all sorts of headlines at the moment all over the world, and we've seen some emerging applications of it in space. So, I wondered if you could start by just giving us a brief overview of blockchain technology in the space sector and maybe focusing on particularly on how it's relevant to satellite ground station services.
I think what we can begin with is just to give a brief of what blockchain is and what exactly it does when it comes to solving problems. The essence of the technology is to actually decentralize a system in order to avoid specific points of failure, like a single point of failure. The other main benefit of using blockchain is that you can actually enable trust. This is pretty critical because at the end of the day, when you want to procure some kind of service or product, you need to have some degree of trust for that. Blockchain technology and some specific features of the technology, such as smart contracts and oracles, can have a pretty interesting uses in providing services in the space industry and specifically in ground station services. So if we have to look into this from the provision of services perspective, one of the main benefits is that you can actually automate the provision of services and turn everything into essentially code, into a digital protocol that replaces paperwork, which is pretty important, especially when it comes to aggregating capacity from different ground stations or providing a ground station service, because you have an entirely new tool that is a lot more agile to actually provide your service and provide guarantees for your service than it would be if you just sign a basic paper-based contract.
The technologies that you're talking about, I mean, you mentioned there that blockchain is often operationalized through smart contracts, and in the ground station segment, such smart contracts must be used to get over some of the critical bottlenecks that ground station services have in order for them to be, more widely used and adopted. I wonder if you could describe some of those sorts of bottlenecks or problems that smart contracts can potentially solve.
For example, one of the things, let's say if you have to provide ground station capacity to, let's say, a space company, a space segment operator, or conversely, if you're actually a space segment operator and you're looking for different providers of ground station capacity, at the end of the day, you will need a specific brokerage service that can basically provide the guarantees and put them in place so that you know that these third-party stations that you're using can be trusted. Or you have to go to this on your own and still end up having specific agreements. Of course, there are specific pros and cons for each of these processes. Doing it on your own is, of course, not particularly efficient. If you run through a brokerage service, of course, you basically gain a dependence to an extent on the broker. Whereas if you actually use a smart contract, you can get into a relationship directly with the provider of the ground station capacity. And the smart contract ensures that the guarantees, that say the payouts or penalties if a service is not carried out, are actually enshrined in code. And this code can be supplied with real world data to assess whether a specific payment can be carried out, whether the service has been finalized, whether there has been some kind of failure along the way. And all of this means that you, to a large extent, you will not need legacy approaches to actually approach third-party providers of a service. But your guarantees are actually enshrined in the codes, and this entire process can be automated and made a lot simpler and a lot faster. And when you actually have this on a ledger, you have provable evidence that specific transaction occurred, that specific interactions actually took place, which is a major advancement over how things would be done through some kind of intermediary service.
Brilliant. So efficiency in terms of compliance, efficiency in terms of complying with auditing requirements and that sort of thing. That's really interesting. So what in particular then is Sfera's vision for addressing some of the challenges that you've described there?
The one major thing that we have in terms of vision is for a very, let's say, broad centralization of ground segments, because this is a trend in general in the entire space industry, and it's also a bit paradoxical because we have an industry that's actually growing quite fast. We have an increasing number of interactions between actors from different jurisdictions, from different regions, different regulatory frameworks that need to obtain trust between each other. But at the end of the day, when you have so many, let's say, different environments from which each of these actors comes, this is going to create a problem for the scalability of infrastructures. Because at the end of the day, you will either need a lot of brokers for these services, or you're going to need somebody who's operating a single network across jurisdictions, or you can actually trust a decentralized system in which the guarantees are basically provided by the code is being agreed upon to be used. And this will allow for a much more organic growth of ground segment capacity. So let's say if you have somebody setting up a ground station in Australia as an individual company, or somebody setting it up in India or in Brazil or anywhere else, by going through a decentralized blockchain-based infrastructure, they have a uniform environment in which guarantees can be provided. And this is going to allow for a much more, like already mentioned, organic growth of capacity across the globe that can be accessed in a way that is reliable. And our vision is to basically work in that direction, provide an infrastructure and toolkits to make this possible, and to, of course, make it possible to decentralize the provision of ground segment services, which of course does not mean that other types of ground segment services are somehow rendered obsolete. It just creates another vector in which the ground station service can be procured, even for those who already can be procured or offered, even for those who already operate specific types of services already.
We hear a lot about the regulatory burden on ground station managers in terms of the licenses required, and then to add on to that, the commercial arrangements that they need to make with their suppliers and their upstream clients. Yeah, and when you're talking about crossing borders, like you say, different jurisdictions, this is a difficult problem, and one that the aptly named smart contracts would seem to be particularly suited to. So, however, such a change in the operations for ground station managers and ground station network providers, how it would be adopted, how it would be able to come about, especially at scale, is that going to require significant changes in hardware and software that's currently used?
Not particularly. In terms of hardware, unless, let's say, station operators or some kind of intermediary links, let's say, process the data after it's been received, need to operate some kind of validation hardware or some kind of very particular type of node that ties up with a specific blockchain. There is no particular need to actually go for other types of hardware or have some special kind of software. Of course, there is going to be a need to manage identities, to actually tie up the specific identity of the provider or the consumer of the service to the blockchain in some way, manage key pairs and everything else that basically allows you to an extent to ensure that the other party is who they say they are. So that's one of the things. And of course, in terms of validating the events that have occurred for the smart contract, it would be necessary to operate with oracles, because the smart contract itself is something that's isolated on the blockchain. So it doesn't really operate with external data or things that don't happen on the blockchain. So if you actually want to interpret an event that occurred between two stakeholders in a transaction, you will need to have an external input that's introduced to the smart contract. That's where oracles come in, which are basically software protocols that translate real world events to the smart contract so that a decision can be made and automated. As an example, I can give you, let's say there was a contact window for a ground station. It's supposed to receive data from a given satellite. But for some reason, the data that is being anticipated to have been received has not occurred. It has not been received and the event has not occurred. So if you need to figure out what has happened and actually automate this process as opposed to making calls, investigating, and so on, you can actually use oracles to identify whether there was a, let's say, a force majeure event or some kind of element of the system did not function according to specification. Of course, this can be configured in any possible way to ensure that security and privacy are preserved. But this entire system can actually be automated. And it's possible that some software configurations may be needed for things like this, but overall, all of this can pretty much run on available hardware, and no specific, very specific knowledge would be necessary to actually make this operate.
And then, I guess, in terms of the introduction of such services as well, the adoption, what steps do you foresee would be required to help convince operators to switch from some of the legacy solutions that you've discussed to an arrangement that's based on smart contracts? And are there particular incentives that could apply at certain times that would, nudge them to accelerate adoption?
That's actually a very good question that touches upon several technological aspects of blockchain. So, of course, when you operate with public blockchain, let's say if you want to do something on Ethereum, you inevitably have the volatility of essentially of the payment method, because when you have to pay with basically a tokenized asset, that asset doesn't have a fixed price, so it's pretty volatile. And that means that if you have to carry out payments over blockchain, then you have to rely on, let's say, an additional implementation, so-called stablecoin, which is something that's going to make it possible to avoid this fluctuation in price and basically solve the volatility problem. So one of the very specific things about this technology is that it allows for a very direct peer-to-peer communication and exchange of value. So a great incentive for somebody who operates, let's say, a ground station here would be that they would directly monetize their capability. So, and this would actually happen quite fast, because whenever you transfer value over a blockchain, that's a process that occurs within minutes, and it's completely traceable and verifiable. And the system itself is made in a way that you wouldn't need to rely on a third party to actually verify that this process occurred. So in essence, there's a lot more control in the consumer of the service and in the provider of the service. They have a lot more freedom to manage their service however they want and to directly generate revenue from, if they provide a ground station service, to directly generate revenue from it, or if they want to consume such services to actually maximize the value that they're investing into the service. So this is actually a pretty good incentive. But of course, there are plenty of hurdles that still remain, because blockchain itself is not a very recognized technology yet. It's still making its, let's say, initial steps in real world use cases, because up until now it used to solve mostly virtual use cases, such that aren't particularly tangible. But now there's actually some very interesting use cases, including such that we've identified in Sfera, where blockchain and tokenization can actually provide a major advancement and benefit in how the services are provided in terms of speed, in terms of traceability, in terms of user control, in terms of actually modifying the service, or in terms of providing agility. So there are plenty of benefits that technology can give, and it's a question of actually implementing those benefits and users understanding these benefits so that they can be incentivized to switch over to blockchain-based solutions.
Finally, I guess we've talked about some of the specific applications and areas for the future. I wondered if you could just touch a little bit more on, maybe a bit more broadly, on how you see smart contracts and blockchain technologies being used in the space industry, reaching a sort of level of penetration in the next up to 5 years, maybe.
We're actually quite optimistic on this, because there is a growing need to replace specific legacy solutions with something that's more efficient, especially as the industry grows. Because, like we already mentioned, there is a paradox between the growth of the industry and the need for increasing trust mechanisms. So the smart contracts and in general, and blockchain technology in general, is a pretty good solution to this. So some specific use cases would be like we were already building on in terms of ground station provision, ground station services provision. Another interesting use case would be access to data. So, for example, if you have specific Earth observation data that is being processed and ready to be used, it's possible to use blockchain to track who actually has that access to specific data sets. Let's see who has used specific data or who has access to specific data set. There are plenty of other non-data related use cases which can come up, which is supply chain management. So let's say you have to track the components for a launch vehicle or something else. And blockchain is a pretty good layer to provide verifiable tracking of the entire supply chain. Access to specific resources is something else that would be a great use case. For example, computation resources or access to a shared satellite service or some kind of, let's say, operational time on a satellite. That's also something that's very useful. Credentials management, identity management for specifically sensitive environments where there needs to be let's say, a role-based access architecture, and you need to see who's actually using what resources. This is a great use case of blockchain. In general, there is a great amount of processes that can actually be, at the very least, deployed on a blockchain or in a more optimal case, tokenized so they can be part of multiple systems that talk to each other. So we're pretty optimistic in the usage of blockchain for this purpose. Of course, there's also other use cases like space traffic management, but overall there are many potential niches in which this technology can actually be deployed successfully.
Fantastic. Well, thank you very much, Zdravko. I think that's a really good place to wrap up. It's been really great to hear all the different insights and application areas, etc., where blockchain could have an impact. And I think our listeners will have found the discussion really useful, particularly with where we are in the wider context of the Web3 movement and a lot of the stuff you hear from outside the industry. So it's great to get the space industry viewpoint on all of this. And that was a really useful talk. Thank you.
Pleasure to be here.
Great, thank you. And to all of our listeners out there, to the whole space industry community, you can find out more about Sfera Technologies in the show notes and on satsearch.com. Our platform has, a variety of information, content and features built to help you conduct trade studies and make procurement requests for systems like this. Whether you're looking for technical documents, quotes, information on lead time or logistics or whatever else you might need for such studies. I really hope you enjoyed the episode, and please remember to rate and subscribe us wherever you get your podcasts. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.